Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we have been covering the topic time series. In time series, in the previous lecture, we have covered two growth curves, which were modified exponential curve and Gompertz curve. In today's lecture, we'll cover the next growth curve, which is next and the last growth curve, which is logistic curve. So let us begin. So as we all know that what was logistic curve? The equation of logistic curve was given by yt is equals to k upon 1 plus exponential a plus bt. Okay, so this was the growth curve. Here K, A and B are three uh, constants. K, A, B are all constants. Okay. So there are two methods. First one is method of three selected point and the second one is Yule's method. We'll discuss both of them. There are another method such as method of successive approximation, and one more method is there, which is Hotlink's method. Those are advanced methods. We'll not discuss them. We'll discuss the two of them. Those are sufficient and easier as compared to the rest two. So first two are method of three selected points. In this again we'll take let T1, T2 and T3 be three equidistant points and has corresponding value as yt1, yt2 and t3. So yt1 can be written as k upon 1 plus exponential of a plus bt1. Yt2 can be written as k upon 1 plus exponential a plus bt2, and yt3 can be written as k upon 1 plus exponential a plus bt3. Okay, so these are the 3 points. So here we can consider yt1. Let us consider yt1. Yt1 is equals to k upon 1 plus exponential a plus bt1. We'll cross multiply and we'll be getting 1 plus exponential a plus bt1 is equals to k upon yt1, and we can say that exponential a plus bt1 is nothing but equal to k upon yt1 minus 1, and a plus bt1 is equals to log of k upon yt1 minus 1. So this is our equation number 1. Now similarly we can get the curves of yt2 and yt3. So yt2 would be a plus bt2 is equals to log of k upon yt2 minus 1, and yt3 would be a plus bt3 is equals to log of k upon yt3 minus 1. So this is our equation number 2 and this is our equation number 3. So first we'll subtract equation number 1 from equation number 2. So it will be b t2 minus t1, b will be common, and here it will be log of k y2 minus 1 minus log of k upon y t1 minus 1. So log of a minus log of b would be log of a upon b. It can be written as log of k minus yt2 upon t2 yt2 upon k minus yt1 into yt1, or we can write it as log of k minus yt2 into yt1 upon k minus yt1 into yt2. And similarly, if we subtract equation 2 from equation 3, we'll get b t3 minus t2 is equals to log of k upon yt3 minus 1 minus log of k upon yt3 t2 yt2 minus 1. Since we know that these points are equidistant, we know that t2 minus t1 should be equal to t3 minus t2. So this equation and this equation would be equal to each other. So substituting the values, we'll be getting log of k upon y. I'm directly writing the formula that we calculated here, this formula. K upon yt2 minus 1 upon k upon yt1 minus 1 should be equal to log of k upon yt3 minus 1 upon k upon log of yt2 minus 1. So here log and log get cancelled. We'll take exponential on one side, then they'll get cancelled, and we are left with k upon yt2 minus 1 into k upon yt2 minus 1 is equals to k upon yt1 minus 1 into k upon yt1 minus 1. So moving forward, we will be getting k minus yt2 upon yt2 into whole square is equals to k minus yt1 upon yt1 into k minus yt3 upon yt3. So this will be the equation that we will be getting. And on solving this for y, we will be getting the value of k as yt1, yt2, yt1, yt2 square, yt1 plus yt3 minus 2 y t1 y t2 y t3 upon y t2 whole square minus y t1 y t3. Y t2 whole square y t1 plus y t3 minus y t1 y t2 y t3 upon y t2 whole square minus y t1 y t3. This will be the value of k, and it's some and if we substitute the value of k in this equation b t2 minus t1 is equals to log of k upon y t2 minus 1 minus log of k upon y t1 minus 1. If we substitute the value of k, we'll get the value of b. And if we substitute the value of k and b in equation a plus b t is equals to k is equals to log k upon y t1 minus 1. Then we'll get the value of a. So by this method, we'll get the value of three constant a, b, and c. So this was our method of three selected points. Rather than solving this, you can directly learn the final answer and write in the exam. So the next method is Yule's method. What does Yule's method say? Yule's method say that if we have any if we have pre-known value of k, or we find out the value of k previously, then we can derive the logistic curve into a straight line curve and solve it by linear system of equation, or system of least square. So I'm writing if the value of k is approximately known or has been calculated by any other method then the logistic curve can be given as, we know that logistic curve is nothing but yt is equals to k upon 1 plus exponential of a plus bt. If we take this on the left hand side, we'll be getting 1 plus exponential a plus bt is equals to k upon yt. If we take minus on the other side, then we'll get exponential a plus bt is equals to k upon yt minus 1, and a plus bt is equals to log of k upon yt minus 1. Since this whole value is known to us, then we can write a constant value which is k, which is v, or any other numeric or any other constant alphabet. So I'm taking v. So I can write this equation as v is equals to a plus bt. So as we see this clearly, then this is the equation of the straight line curve, which we have done in our first when we started this curve, then the first curve which was straight line curve. If you don't remember that, then you can see that in the one of the previous lectures of time series. This is a straight line equation. So this can be solved by, this can be solved by the method of least square. How will we take the least square method? So the method would be, we will take E is equals to summation T goes from 1 to n V minus A minus BP is equals to 0. First least square would be this, and the second one would be, we'll multiply it with T. So let us write this first. T is equal to 1 to n V is Vt minus Na minus B summation T goes from 1 to n is equals to 0. So this will be our first normal equation. And for the second normal equation, we'll multiply each with T, because there are, we'll take out two variable, because we have to find out two value of two constants A and B. Then we'll first of all we'll multiply by summation T. In the second case, we'll multiply by summation T into T. And if we would have constants more than that, then we would have multiplied with likewise with more numbers of T. So it will be T Vt minus A summation T goes from 1 to n T minus B summation, here it will be T. T goes from 1 to n T square is equals to 0. So this will be our second normal equation, and by solving both of them, we'll get the answer, or we'll get the values of constant A and B. So these were the two methods that we had to do in our lecture today. I hope the growth curves are all clear with all of you, and if not, then you can ask in the comment section, or you can write your queries on our WhatsApp channel. Only relevant doubts will be answered. Keep on working hard, and keep on revising the topics that we have already done. And if you haven't covered those videos, then you can check on our channel and revisit those videos again. So all the best. Thank you.